Good afternoon, everyone. My name is Cristobal Lopez. I am an enterprise solutions architect in AWS. I've been in AWS for 3 years already. I'm specialized in networking, and I'm working with finance customers in the Iberia market, so Spain and Portugal customers, implementing solutions on AWS. And with me is my colleague, Francisco.
Hi there, good afternoon, everybody. I'm Francisco. I'm Technical Account Manager at AWS. And for those of you that are not familiar with this role, the TAM, we usually work with enterprise support customers, and our goal is to focus on help them in the cloud journey in terms of key topics like security, cost optimization, resiliency, and so on.
So our talk today is going to be about or around building open source firewalls in AWS. In this case, with Suricata, there's many options that we see our customers implementing on AWS for protection, for networking inspection, security. But due to SuriCon's conference, we're going to be talking about Suricata solution, of course. So what we're going to talk today around the AWS implementations of these services. First, we're going to have an introduction to AWS Gateway Load Balancer, the kind of load balancer that most customers use to deploy a solution like this one. We'll also talk about AWS Transit Gateway and multi-VPC routing. So VPC stands for Virtual Private Cloud. It's the basic kind of network that we can have in AWS deployed. Then we're going to have an introduction to the AWS Network Firewall. And finally, we're going to have a hands-on workshop for Suricata on AWS. It's not something that is intended to be finished during this presentation, but it will be introduced to you, so you can have actually, you will have around 2 or 3 days to complete this workshop. You can log in at the end of the session and have an AWS account for each of you available to do the workshop and see how to implement a Suricata solution and a network inspection on AWS. And that's, of course, for free and out of cost for anyone trying. So just to get the sense on the expertise on AWS from the people, is there anyone that has already played or deployed anything on AWS already, or is this new to everyone? No one? A couple hands only? Okay. Nice. And so we're going to set the level at a basic level on AWS. So if there's anything that you don't understand, we'll get to the questions at the end, but I'll try to make everything like really simple in AWS terms related. So this service of the Gateway Load Balancer comes to solve one issue that, or a situation that we see a lot on customers when starting implementing solutions, which is when we have the inspection of some traffic with a source and a destination. I want to do inspection or security between the traffic of the two instances, and we deploy just one instance maybe, or we deploy 2 servers in an active-passive way. We might run into some issues like having a single point of failure. What happens if this instance fails? Do we have to create an automatic failover? How well does it work? What happens if we have an active-passive and both instances fail? We do run also to limited vertical scale. What happens if we have peaks in traffic and the server is not able to respond to that peak on the traffic? Also, we have the problem that the passive appliances are sitting idle, and we might be losing these resources that could be used in something different, or we can be even paying for that if we're having that solution already deployed. Also, we have disruptive interaction with this model if we switch from an active instance to a passive one in case of a failover, for example. And also we run into mixed administration domains when it comes to the people managing the networking and people managing the security. It comes to like sometimes we step on each other and we might run into some issues of some people doing configurations that are causing problem in the other team's domain. And the solution that is proposed by AWS in order to solve this or try to put a solution to this problem or to these several problems is this figure of the gateway load balancer, which will be sitting in front of this appliance fleet that we can have. In this case, for example, for SuriCata or any other third party that we have on the market. And this gives us this fault tolerant because the traffic is going to be load balanced between the different instances deployed. We can have the elastic horizontal scaling in case we have peaks of traffic. We can adapt to the demand that we have on our servers. We can have active fleet, so without having any idle capacity that is not doing anything. Also, we can have transparent insertion on this model, and also having the isolated admin domains, as the networking people would be managing specifically the networking part of the domain, so the gateway load balancer and the security team or the security responsible is just in charge of the things related to the security of the appliances and not having to worry about how the traffic is actually reaching these instances. So in the end, like gateway load balancer, it helps us reduce the complexity and make a deployment faster. Also, it allows us to elastically scale and reduce the cost, as we're not going to have some extra capacity that we're not actually using. It will help us achieve and improve our appliance availability. So the deployment that we can do is not only for depending on one instance, but we can have a fleet of instances in which to rely on. And finally, it's really important that it was built from the basis that it could support all the leading supplying vendors, and not only the third-party vendors, private vendors that we have, but also open source solutions like SuriCata. So the benefits for our customers in this case is that you can use already your existing third-party appliance skills. There's nothing new in that sense that you have to deal with. So you can leverage your existing tools and practices in order that you're using for the traffic inspection analysis. It will simplify the appliance deployments, and as there's just a matter of managing the image that is going to be used for the deployment, and the deployment, once set automatic, there's nothing on the operations to worry about. We can deploy appliances at an elastic scale, improve the availability, as I was saying before, and not only that, but also if we move into a bigger organization environment in which we may have different virtual private clouds or different AWS accounts, we can also share the appliance across them, so it gives us a way of sharing the responsibility between the different teams that are accessing the different resources that they're in charge of. So how's the gateway load balancer traffic flow in this case? Imagine that we have a source and a destination, and there's traffic that is going to go from the source to the destination. First, the traffic will go to the gateway load balancer instead of going directly to the instance. But the gateway load balancer in this case is in charge of acting as a layer 3 gateway, so having the next hop in the route table in which it is sitting, and there's no packet rewrite, so the packet is going to reach the SuriCata instance in this case without any kind of rewrite, so completely transparent. And this is due to the encapsulation of the original traffic that is going to reach the instance first being encapsulated with the Geneva protocol, and then it's going to be the encapsulated one just before reaching the instance, so the instance is reached as if there was no load balancer before. We're going to have the level 4 load balancing for scaling, for stickiness, for the health checks to be sure that our instances are working properly, and if not, to do the failover and the flow rerouting. So everything, all of that is managed. So the traffic is going to arrive to the instances depending on the load of the instances, or if there's any stickiness it has to adhere to. Then the traffic is going to go back to the load balancer once expected and hopefully permitted. And finally, it's going to arrive to the destination. So with this, we're going to achieve several benefits. First is the scale, the reliability, the transparent section, which in this case also gives us this due to the encapsulation. it's really important to note from my point of view that we can use this in the end as a service, because the gateway load balancer, when implemented on our network architecture, is going to be seen as just an endpoint. So that's something that once configured, this part of the gateway load balancer, this gateway load balancer plus the third-party appliances, just by situating the endpoint on different networks, we can have that inspection provided as a service. And finally, that it is an AWS native service. And what does this mean, or why is this important? As you might have realized, I haven't spoken about anything related to the managing of the infrastructure underneath the gateway load balancer, or the amount of instances that are going to be needed, or how to manage the scale of this balancer. And this is why this is because it's this being AWS native service, that means that it's completely managed by AWS, so we don't have to worry about any of this infrastructure part. That is completely managed by AWS, and we can rely on that. The availability and the scale is going to be already provided by the service. So the top use cases for gateway load balancer are, first of all, we see it a lot for partner solutions being implemented for firewalls, for IDS, for IPS, also for network visibility and analytics, and also for DIY, for custom Linux inspection appliances, of course, cases like SuriCata in this case. So how does it look, distributed design pattern, when it comes to the traffic inspection, or when being deployed on AWS? For this, imagine that we have, in this case, is represented by two, what we call, in this case, spoke VPCs, so two different networks that are working in parallel, so without any kind of interaction between each others. Imagine that we have different applications on these virtual networks. We can see that we have some application subnets to the right in both VPCs, and also we have the front end of each application. And within each front end, we have an elastic IP, so the ingress IP for the load balancer, and this purple logo, it means that it's an elastic load balancer, and this load balancer is going to be distributing the traffic to the appliances. So this would be a common pattern, but how do we insert here the traffic inspection? For example, if we want to use a solution that, like what we were mentioning with SuriCata gateway load balancer. So for that, we will be including a subnet, which will be the entry point of the traffic coming from the internet. And in here, we will have the endpoint, which is the endpoint of the gateway load balancer. So in the end, we would end up having a traffic like this one. So imagine that the traffic coming from left to right, the traffic coming from the internet. When it arrives to the spoke VPC, it arrives to a virtual element on AWS called the Internet Gateway. That's the IGW that has its own route table in this case, and we can see that the traffic that is routed to our private network, so the /24 is pointing to or redirected to the gateway load balancer endpoint. Once it reaches the gateway load balancer endpoint, what it's going to do is send the traffic automatically to the different instances that we have running the SuriCata firewall in this case. That can be even in these VPCs, or it can be in a different VPC, in a different AWS account, so we have the flexibility to set the inspection wherever we want to. After the traffic is inspected, it goes back from the appliances to the gateway load balancer endpoint, and here it will send the traffic, in this case, to the elastic IP, so where it was heading initially in a transparent way, and then the load balancer will route the traffic to the instances, and the path back will be similar. So it will go from this elastic IP of the network of the elastic load balancer, will go in this case. It has the route to the internet to the gateway load balancer endpoint, and this way, after going to the endpoint and being inspected, it will go back to the internet from when it came at the beginning. This way, how how a user can see the traffic in the different subnets that it's going to have. So the VPC ingress routing is going to look like this. So going from the internet to the gateway load balancer endpoint, then going to the elastic load balancer that will balance the traffic throughout all the different instances that we have running in our application. And this way, we're introducing the transparent security to our applications hosted on AWS. So this was the distributed model in which we have, for example, like different VPCs that are exposing services to the internet, and we have this endpoint situated in every single virtual private cloud that we have. But we also have, and see a lot on customers, a centralized design pattern. So this centralized design pattern is a model we call hub and spoke. That's why I was talking about before the spoke virtual private clouds or VPCs. And in this hub and spoke model, we have this service called Transit Gateway that you can think of I like to say a switch that it's on hormones. Like it can do way many things than what a normal switch would do, but it's kind of a way of thinking about it. So we can attach or join the traffic from the different spoke VPCs to this transit gateway, and within the transit gateway, decide which networks are going to be able to see other networks and what's going to be the routing of the different traffic coming from the different networks when it reaches the transit gateway. So in this centralized design pattern, what we can see is the path of the traffic, for example, when it goes from the source of a spoke VPC and it wants to go to the internet. So instead of allowing every single VPC to have its own inspection with the gateway load balancer and then having any kind of nothing, what we can do is having this central model in which we send all the traffic to the transit gateway, and within the transit gateway have the specific route that tells us, okay, so all the traffic going to the internet, so like the 0000/0, is going to be sent to this centralized appliance VPC where we're going to have the inspection. All the traffic coming to the inspection VPC, how we can call it, is going to go to the gateway load balancer endpoint as before, but in this case, everything is contained within the same virtual private cloud. We're going to have all the inspection here, and the traffic that is accepted based on the rules is going to follow to the internet. In this case, for example, going to a NAT gateway or a NAT instance, and then are going to the internet. And the traffic back from the internet is going to follow the same. It's going to follow the same pattern, but backwards. And also, here, not only we can filter the north-south traffic, so the traffic going to the internet, but we can also filter or inspect the east-west traffic. So imagine we want to go from the spoke VPC1 to the spoke VPC2, because there are two projects or two microservices that need to speak to each other. We're going to have, as we have the default routes going to the transit gateway, everything in the transit gateway is going to go to the inspection or the appliances VPC. The traffic, again, is going to be inspected, but after the traffic is inspected, due to the route table that we have here, instead of going to the NAT gateway and to the internet, it's going to go back to the transit gateway, and from the transit gateway, seeing that the traffic is pointing to some of the other networks on our private network, we're going to be able to reroute the traffic to its original destination. This way, we can achieve at the same time both east-west traffic inspection and north-south traffic inspection, and this scales to the number of virtual private clouds that we want to add. So this is a solution that we see large enterprises use, as it provides them with the scale necessary to be deploying inspection on AWS. So now, as I was saying, we can have this centralized security inspection with Transit Gateway, and we end up with a picture like this, in which we can have VPC 1, 2, 3, as many as we want, and scaling with our business needs. And we have this central piece, which is the Transit Gateway, and we have the central inspection, which is the gateway load balancer plus the firewall fleet, and we can have both north-south inspection and east-west traffic inspection. And we can even have this outbound internet access that can be within the appliances VPC, for example, or we can have even a separate VPC for that. So in this case, the objective was to, normally we see customers that want to achieve this both north-south and east-west traffic inspection, and we have to manage the gateway load balancer, which, as we were saying, it scales automatically, and it has the automatic, the elasticity and resiliency needed. And we have to manage the firewall fleet. In this case, we only have to manage how we want to handle the scale, so like the auto-scaling, but also we would need to be in charge of everything related to managing everything related to the instance. So the patching of the operating system, the software updates, anything that is related in the end to the image that we have in this auto-scaling. So also, we can see this as not a problematic, but something that can be also improved in order just for the security team or the networking team not to be focusing on the underneath of the value, which is the software. So trying to avoid managing what would be the image itself. And for that, AWS also proposed what is the next solution that my colleague Francisco is going to talk about, which is a network firewall.
So thank you, Cristobal. I will continue the presentation from this point. Yeah, you mentioned the AWS Network Firewall, and maybe one thing that I would like to call your attention into is, if you look at this slide, you can appreciate that there is no longer AWS Gateway Load Balancer there, meaning that we are somehow providing you a managed service, in this case the Network Firewall, that is implementing the Gateway Load Balancer functionality internally somehow. You don't need to care about that. And the basic idea is that there are many customers in the field that can benefit from this approach, meaning using a managed solution, in this case the network firewall, and trying to simplify as much as possible the management overhead that implies to manage explicit infra. In this case, what customers can do instead is focus on the security policy. And by the way, good news is that part of the security policy, you can leverage Suricata-style rule syntax for this. So, introducing now the network firewall, one thing very interesting also is the fact that this is no upfront commitment in terms of cost, meaning that customers only pay for what you use. So in that regard, coming back to the comments from Cristobal, let's think that you don't have to pay for idle instances anymore. Of course, we are providing a solution that is highly available, meaning that customers can have the flexibility to deploy the network firewall in an inspection VPC and in different availability zones so that the solution is highly resilient. And another interesting topic for the network firewall is the rule engine. You can combine the AWS managed rules with your own customer specific protection rules based on Suricata. And regarding the design, we see that customers use the network firewall in different ways. For instance, there are some customers that go to a centralized approach, perhaps a more traditional one, but there are other customers that go in different way using a distributed or decentralized approach, meaning that they can deploy as much firewall endpoints as needed, depending on the business objective or requirement. Being a cloud-native service means that it's very easy to deploy a firewall endpoint and have something capable of protecting the environment in a matter of minutes. So now, going a little more into detail on some of other capabilities for network firewall, one thing that I think is key is also the throughput, how the firewall is able to scale per endpoint, meaning when you deploy the firewall, you deploy a firewall endpoint for every availability zone within an inspection VPC and within a subnet. And for every instance of that endpoint, you can scale unto 100 gigabit per second at the moment. Now, regarding flexibility, because we are talking that you can leverage Suricata rule syntax, you of course have all the flexibility that Suricata offers in this regard. And you can also, something that we have been discussing today in other talks, regarding the majority, right now, the majority of the traffic in the internet, meaning public traffic, when we talk about HTTP traffic, I believe is something like 85% is encrypted. So in case you need to decrypt the traffic in order to inspect in the firewall engine, you can do that because we support TLS inspection. We support both in the ingress path and also in the egress path. Following with more topics, managed rules. You have the possibility of leveraging the AWS managed rules in terms of security protection, meaning threat signatures and malicious domains. For instance, you can prevent your business applications from communicating with a well-known malicious domain. And regarding observability, it's worth mentioning also that this service is natively integrated into the CloudWatch metrics. And regarding logging, we support different logging destinations. For instance, Amazon Object Simple Storage Service, CloudWatch Logs, and also Kinesis Data Firehouse. More topics regarding regulation and compliance. This is, of course, an important topic for many customers. We support several important standards like PCI, SOC, HIPAA, and others. More topics, perhaps on the part of integrations with the fact that many customers are using many security solutions at the same time. And you need somehow a certain degree of integration between those. We have several options in the AWS marketplace in order to integrate the network firewall with other solutions. And the last one is also very important, is the fact that many customers need these days to manage all the cloud infrastructure using code. So for this, we also support managing the network firewall via CloudFormation or Terraform. Now, if you are wondering who is using currently the AWS network firewall, we have several case studies already available in the AWS website. We have chosen this one in order to show very quickly to you, but there is something that we can tell, is that AWS itself is using internally AWS Network Firewall for processing a big amount of traffic every day. You can see the figures there, 250 billion daily connections. And this is an interesting case note to take a look, because we were able to improve the efficiency, be more scalable in the sense of attending increases on the traffic demand, be more resilient, and also reducing the networking ticket overhead with managing all the other solutions. So now, having talked about the AWS Network Firewall and other products, let's head over now to perhaps a more interesting subject for you, which is the hands-on. As Cristobal was mentioning before, we have prepared for you folks a very interesting workshop scenario you can play with. I think it's going to be available until Friday, 4 p.m. or something like that, so that you can play with it. And the basic idea for this workshop is that you are going to see how you can deploy your own Suricata solution, in this case in firewall mode. And you are going to see how to integrate with gateway load balancers to make the solution highly resilient and scalable. And yeah, it's a hands-on exercise, so I hope you have some time to play with it. So in order to, because the scenario you are going to be able to deploy and play with it is kind of complex, especially for the people that are not very familiar with AWS at this point. We have prepared here a simplified diagram so that you can see how the traffic is going to progress in your environment. So starting with the north-south traffic, meaning traffic for, let's think about a VPC where there are some EC2 instances that need to communicate with the internet. As you can see following in the arrow in the slide, the EC2 instance is following best practices, is located in a private subnet, and is going to send the packet through the local subnet. There is a route table consultation there. The next hop is going to be a NAT gateway in order to provide proper NAT translation, address translation in this case. The NAT gateway is located in an intermediate subnet. Is going to, once more, check the destination. Is going to be a public destination. So in this case, due to the inspection security requirement, we need to redirect the traffic to a gateway load balancer endpoint. In this case, the magic starts to happen because the traffic or the packet, let's think about a TCP SYN packet, for instance, for simplicity, is going to arrive through the gateway load balancer to the fleet of Suricata firewall instances running in EC2. The gateway load balancer is going to apply a hash algorithm in order to apply stickiness to the session and ensure that there is a stateful there, meaning that the same traffic flow is going to be analyzed by the same Suricata instance in this case. Hopefully, after an analysis, the packet could be allowed. So it's going to progress back into the original VPC and move forward to the internet through the internet gateway in this case. Now, for the reply packet, let's think about a TCP SYN ACK. The reply is going to follow a similar procedure. You can see very quickly that goes back to the Suricata appliance through the gateway load balancer, is going to be allowed potentially, and then from there is going to travel to the original VPC and go back through the NAT gateway and do the translation and finally arrive the EC2 instance. So this is an example for north-south traffic. Now, the other example in this centralized design is east-west traffic. Let's think about perhaps two microservices that need to communicate between each other. Let's think between VPC1 and VPC2. In this case, the central routing mechanism that you are going to see in the lab is the transit gateway. So the packet is going to arrive to the transit gateway. The transit gateway is implementing different routing tables depending on the VPC attachment where the traffic is entering from. In this case, it has a clear instruction that is all traffic that is coming from an application VPC needs to be redirected first to the security VPC. In this case, the same approach as before follows for Suricata inspection, and then the packet goes back to the transit gateway and all the way to the destination VPC. And yeah, for the sake of time, the reply follows the same approach in reverse order, meaning reply, transit gateway, inspection, going back to the transit gateway, and arriving to the original EC2 instance. Now, in order to give you more detail so that you have a clear idea of the scenario you can implement, this is composed of 3 labs. The first one is about deploying the basic networking infra in AWS. In this case, you are going to see how to use CloudFormation for deployment, and then you are going to see how to use the AWS console to deploy a gateway load balancer from scratch. And perhaps one of the most important parts is see how to configure routing within your AWS infra. The second part of the lab is perhaps the more interesting because it's about seeing how to implement from scratch a Suricata firewall running on EC2, and you are going to be able to customize. In this regard, I assume you are very skilled in this topic, so you can play with it, you can customize the firewall rules, and also an interesting topic is the cross-availability zone problem. You are going to see how you need to take care of keeping symmetry when it comes to traffic that potentially can cross between different ACs. In this case, you are going to see details on how to keep symmetry so that the inspection in the Suricata level is properly applied in both directions. And the third and last one step on the lab is scaling the solution, meaning you are going to see how to create an auto-scaling group in AWS and allow the Suricata solution to scale as needed. And yeah, it's about having some fun. So hopefully we invite you to join the workshop and have some fun.
Can you please leave the QR codes during the questions? Thank you. Of course, if there's any questions related to the session, we're happy to answer. Just also to make sure that everyone can access the workshop. That's the main concern. That's the most important thing, even more than the feedback survey. So hopefully, when next year we ask again who has joined sometime the AWS console, everyone puts up your hands because all of you are joining the workshop today. We can see. Oh.
Just a quick question for clarification. You mentioned the ability to do TLS inspection. Does that mean you're inspecting the encrypted traffic, or do you actually offer some type of SSL, TLS man-in-the-middle service offering?
Yeah, I mean, let me know if I didn't get your question, but it's about how maybe we support TLS inspection in the ingress path, meaning potentially let's think about any kind of service that customers are publishing on the internet. In this case, you need to provide the certificate, private certificate key and so on to, to decrypt the traffic on the ingress path before arriving to the firewall engine. That's one. And also for outbound traffic, if you need to do TLS decryption there in the egress path, you need to apply a different methodology as required and so on. But I don't know if that's the question.
Yeah, that answers it. Yeah.